Hello Year 10. Today I'm going to look at terminal velocity. Now remember, velocity is speed and direction, so going a certain distance in a certain time in a certain direction. So terminal velocity is talking about two forces acting on each other. For example, this guy standing on the ledge, there's a force acting upwards on his body and a force acting downwards on his body. The downward force is his weight, which is really mass times 9.8 meters per second. That is the gravitational force of Earth. And the upward force could be from this ledge itself. When two forces are equal in opposite directions, then we're going to say that there could be terminal velocity. Of course, at that time, an object needs to be moving. So put a heading terminal velocity and write down what is weight. And you could draw the stick man on a ledge. You could draw him as a stick person. And you can label the upward force and the downward force. Downward force being the mass. And there are two opposite forces acting on this person. Having a look here at the two objects, if this one is stationary and the two forces acting in opposite directions are equal, it will remain stationary. And if this one is already moving, this object, and the two forces are equal in both directions, it will travel at constant velocity. If one force is greater, like shown by this arrow, then you're going to have, and this force is less, you're going to have an acceleration, an increase in the velocity. So in your book, I'd like you to draw this to show two opposite forces acting on an object. If the forces are balanced, it will not affect the motion. If it was moving, it will continue to move. If it was stationary, it would stay stationary. But if the forces become unbalanced, the push is greater from the left than the push from the right, so there's going to be acceleration in one direction, in the direction of the greater force. So pause the video, write that down please. Having a look at other forces when someone is already moving. So we've got two people on bicycles, and we know already that they have a force from their actual mass and the force of gravity, and they're moving their legs, causing velocity. One person is bent over, one person is just sitting up straight. Which person would show the greatest increase in speed or acceleration? Now the force that's acting against this person, shown by the arrow, being air resistance. So why is this person faster than this one? Well, there's a larger area here for air resistance, so this force will be greater against the actual moving force of the bicycle. If we have to look at resistance in a parachutist, the force pulling him down towards gravity is weight, and the force pushing up into this parachute is air resistance. So there are two different forces acting in opposite directions. But the actual velocity of this person moving out, falling down from the sky, would change with time. So air resistance, an object experiences resistance as they move through air. That means the air is pushing up against the surface of their body. So which force is greater when he first jumps out the plane? Is it air resistance or gravity? Maybe you could draw a stick person, flat eagled, spread out, and you can label the different forces. So the force acting up, the upward force is air resistance, the force acting down is weight. So once you have labeled those two forces, can you say, what does terminal velocity mean? So basically, if these two forces are balanced on a moving object, it will remain moving at constant velocity. So here we have a hot air balloon. There's air resistance pushing up into this hot air balloon, and we've got gravity pulling it down. Objects fall to ground due to gravity. Which force is greater if we lift the air balloon? To lift the air balloon up from the ground, which force is greater? Well, you should be able to say that the upward force is greater, so you should be able to say that it is the air resistance. Which force is greater to reach terminal velocity? You should be able to say it is none of them are greater, they're both equal. So weight and air resistance are equal at this point. So it moves then at constant velocity. And to actually bring this balloon back down to Earth, what would they have to do? They'd have to reduce the air resistance so that gravity is greater. So they have to be less air resistance. Can you write these in your book, please? Pause the video. Here we have an example of different masses. It's the same person that's jumped out of the aeroplane, and as he starts to fall, due to the weight being greater, air resistance, this opposite force starts to increase, and it gradually increases all the time. And at what point does it reach terminal velocity? So the downward force is always 882 because it's the mass times gravity. But the upward force, something is starting to increase, the air resistance. At what point does he reach terminal velocity? When the upward force equals the downward force, air resistance is equal to gravity, then he has reached terminal velocity. So, can you write a sentence about what is terminal velocity and why this person reaches terminal velocity? If we look here, we see the acceleration initially is 9.8 meters per second. As air resistance increases, it changes to 6.5 meters per second, 3.1, until acceleration is 0 meters per second. That doesn't mean he has stopped falling from the sky. It means that the upward force is equal to the downward force. So the terminal velocity, the velocity is constant. Please make sure you understand that. It doesn't mean that he has stopped moving. That object or that person is now traveling at constant velocity. Here are two parachutists with a brown parachute and a blue parachute. When the air resistance is greater than the gravitational pull, the force of gravity, then it doesn't mean this person is now going up into the air. What it basically means is that he has slowed down. there is less acceleration in his movement. When the accelerations are equal, the acceleration will be constant here or velocity will be constant when the upward force is equal to the downward force. So that is moving at constant velocity. Please write a sentence about this. When the upward force is greater, what happens to velocity? Can you write a sentence, please? So you should have written your answer by now. You can always pause this video. When the upward force is greater, as in here, then this falling object or this falling person has slowed down. That does not mean he goes back up or higher in the sky. So here is a graph. It shows you that initially when the person jumps out the plane, there's acceleration because gravity has got a greater force. At which point do you think he starts to open his parachute? Well, that would be when acceleration slows down. Would be round about there. And then at what point do you think air resistance is equal to gravity? Would be at this point. And what do we call that? Terminal velocity. Which force is greater in the first minute? Can you answer that in your book? Which force is greater after 1 minute? Answer in your book and give a reason why. Pause the video. Right, so you did get this worksheet last week. Yeah, when gravity is greater, we'd have to say that this person is accelerating, he's moving really fast, the speed is increasing as he goes towards the ground. After a while, because his body is spread out, air resistance starts to increase and basically he will start slowing down. He will still move, but he will slow down. And then eventually when the two forces are equal, the forces would be balanced, and that would be terminal velocity. After a while, he will open his parachute. The air resistance will be greater than the gravitational force. So this means actually he will slow down at this point 4. And at point 5, when the two forces are equal, we'll have reached terminal velocity. So here in 4, air resistance is greater, the forces are unbalanced, and gravitational force will decrease over here. Over here the two forces are equal and you will move at terminal velocity. You did get this worksheet, but I'll still attach it again, and you can do this in your book to label that. You can check your answers. Right, so talking about a falling object, as in the parachutist, we can say that acceleration is due to gravity, which is 9.8 meters per second. It's pulling an object downwards. And we do not maintain this acceleration as we move through the air, because as we move through the air, some kind of resistance is increasing. What is moving up against that falling object? You can use one of these terms here to help you. Which one is it? Then as a falling object speeds up, the what acting up against the object, it's going to increase. The air resistance, that one, increases. And this causes the unbalanced force and acceleration to, so it's the opposite force. What happens to actually cause acceleration to decrease? And eventually both objects will reach a point where they are balanced, both forces. What is the downward force? What is the upward force? So that the object that has been falling is balanced. From this point, it will continue to maintain what kind of velocity? Can you pause this and write this out and then continue with the video when you're ready? Sorry. So yeah, we have answers. Although acceleration is due to gravity, the downward force, objects do not maintain acceleration, so they don't continue to speed up as they move and fall. And the reason is that because there's an upward force. That upward force is air acceleration. And as an object speeds up, the air resistance acting upward increases. It's acting upwards, but it doesn't mean the object travels upwards. And this causes an unbalanced force, so acceleration decreases. It slows down. The object stops falling as fast as it normally does. And eventually the object will reach a speed where the upward force, called air resistance, balances with the downward force called weight. When these two forces are balanced, air resistance and weight resistance, we will reach a point where terminal velocity or constant velocity takes place. Please mark this in your book and do any corrections or just give yourself a tick. Well done. Right, looking at this, are there two opposite forces here acting on this boat? What do you think? So here is a little boat. There could be two forces, one acting down, gravity, and one force acting upwards. We call that upthrust from the water. But there's a third force that creates movement. So this one throws us out a bit. It's the force of the motor that creates the acceleration of the boat. So there's just a different type of question. Right, so to define terminal velocity, it's a point where a free-falling object experiences zero acceleration. And this is because of air resistance. The upward force balances with the downward force. Please pause the video and write this down in your book. And then looking at the graph for terminal velocity, what we can see here is that an object first starts increasing in speed because the downward force is greater, that is gravity. At what point would this person then have opened the parachute? Probably as soon as we can see a slowdown in acceleration. So the upward line or the trajectory has slowed down, and so that we could show the parachute is open due to air resistance, slowing down the falling of that parachutist. And then when it reaches a constant velocity or terminal velocity, this is where we'd say the two forces are equal. Can you draw this graph in your book? On the x-axis, velocity, and on the y-axis, time, sorry, velocity, and on the x-axis time. So you're drawing this graph, and at this point where it starts to level out, a flat line, that means terminal velocity. Where it's increasing, the line increases at an angle, it shows acceleration, and then when it starts to curve, it's slowing down because of air resistance. The parachute would have opened. This could happen also in water. For example, in liquid, if you just take your hand, flat hand, and you push it through the bath water, you'll feel that resistance. In fact, you might even create waves. So you've drawn this graph. Pause the video and continue. Right, some questions to finish off. Which force is greater when the parachute jumps out of the plane? Well, it's obviously the weight. So what will happen to his acceleration? Acceleration due to gravity will increase. When he first opens the parachute, there's a resistance, and there'll be a decrease in downward acceleration as air resistance increases. After the parachute is opened for a couple of minutes, the upward and the downward force are balanced, gravity and air resistance, and that's causing terminal velocity. And then finally, just before the parachutist lands, there will be less air resistance. As it gets closer to ground, the parachute might start to actually be less inflated, and so you would hit the ground. Acceleration then cannot be constant. If there are any questions, you'll post them on Teams, or you will actually send me an email. Thank you.